everyone, it's Mr. Canfield. Today we're in 4.9 and we're going to start with our activity essentials only. I'm going to try to lead you through this activity the way that we would do it in class. First, I'm going to move the paper and readjust it because I fidget. Okay, so let's look at these directions here. It says mathematicians figure out what's essential and learn how to eliminate or ignore what's not. Yesterday, well, last time, we found that knowing just a few measurements was enough to determine if two triangles are congruent. Are there any other essentials? Let's find out. So a big thing for today's notes is that these are not drawn to scale. It says, note that the triangles in these problems are not drawn to scale, so you won't be able to rely on ruler measurements or eyeballing. So do these look the same? It doesn't matter. We want to see if the numbers match up. And I know when I draw triangles in class, I almost never try to draw them to scale. I just draw some random triangle and then we talk about it. Because it's the numbers that make things work. Okay, so look at the two triangles shown. What is the same about the two triangles? What is different? Well, I was gonna say they look really similar to each other. That's the first thing, but let me look at the numbers and actually see if I see anything. 4, 7, 5, these are not the same numbers, okay. 52, 85, 43, 52, okay, so they have the same angles, but the sides are different. So we would not classify these two triangles as congruent to each other because their sides and angles all have to be the same to be congruent. But, I feel like there's a connection here. 4, 12, that's like 8 more. 7, 21, that's like, no, it's not 8. What about 4 times something to get me 12? Is 7 times 3, 21? Is 5 times 3, 15? So this triangle is a scaled up version of this triangle. They are not congruent. They're something we call similar, which we'll deal with a lot later. But for now we know that they're not congruent. All right, what about in this situation? They've got the same angles again. Oh, exact same angles as the last time. And then, but now I've got a side of 4.1 right here. Do I just triple it to get? No, wait, no, we're doubling it. We're doubling it this time. So if I want to find the missing sides, oh wait, well then I can take 2.8 and double that. 2.8 times 2, that's 5.6, so that'll be that one there. And then the 3.3 on the bottom, we can double that and get 6.6. So our scale factor was 2. So are the two triangles congruent? No. How do you know? Because the scale factor is 2. It scales up, and the sides need to be the same to be congruent. Well, let's look at the third triangle here. Or the third pair of triangles. Let's see. Same angles again. No, we start with 4.1 again. But this time 4.1 scales to 4. Wait, that's the same number. Wait, so if that scales to the same number, then this is going to scale to the same number, and this is going to scale to the same number. Wait. So then this is going to be 2.8, this is going to be 3.3, 4. Now we have two congruent triangles. Because all 3 angles are equal. And all 3 sides are congruent. Remember, we need both of those things. So, but we were able to get this just knowing a single side and that the angles were equal. So, the next page of your packet, I think I messed up when I copied this. I don't think you have this page. Just kind of talk with me for a minute. Actually, don't talk with me, because if you are talking with me, you are talking to a video, and that's a little strange. I'm not going to tell you how to live your life, but you know. The first question here says, is there enough information to determine if the triangles are congruent? Explain. So let's see. They've got the angles. Okay, so they have the same angles. Is that enough? Is that enough to guarantee the sides and the angles match perfectly? Well, let's go back to the previous page for a minute. Here, these two had the same angles. But depending on what the sides were, they weren't necessarily congruent. They were only congruent if the sides matched too. So since we don't have any information about the sides, no, we do not have enough information. We don't know scale factor. If the scale factor is 1, like if it's the same, well then cool. But if it's not, then we can't know. Well, let's look here. The angles match up again, and now we have a scale factor, right? So 2.3 scales to 2.3. Oh, okay. Interesting. Yep, they're similar. Means all the angles are equal. And our scale factor is 1. Is there enough information for these ones? Let's see. Now this one might seem a little trickier at the outset, because we only have 2 angles given. We've got 115 and 30. Oh wait, but that's 115 and 30. Here's the thing. You don't need to know what this last one is. You know it's the same, right? Because 115 and 30, you take them away from 180, you get something here. 115 and 30, you take them away from 180, you get the same thing. So that means 2.7 here in both of these is across from the same angle. And if you're annoyed that I haven't found it, okay, I'll find it. Let's see, 180 minus 30 is 150, and then minus another 115, what is that? 35? So this is 35 degrees. So 2.7 is across from 35 degrees both times. That's it. So that means that 2.7 scales to 2.7. We got a scale factor of 1. Yeah, we got 2 congruent triangles again. I think I was about to say 2 congruent triangles, because we drew congruency. I don't know. I can't speak. So we're going to talk about what kind of congruency this is in a few minutes. Oh, good job, Canfield. I had printed out 2 copies of this so that I didn't have to deal with this mess up here, but I used the wrong copy. So, all right, what about these 2 triangles? Let's see, they got the 68 and the 57, and the 68 and the 57, and they both have a 9. The key thing is that this 9, if it's going to be a congruent side, it needs to be across from the same angle each time. So 9 and then 9. Okay, we're good. Let me show you a scenario where it wouldn't be what we want. So let's say we have the exact same first triangle, but instead in our second triangle, 68, 57, instead of 9 being here, 9 is over here. This is a situation where I know then that they can't be congruent, and here's how we know. If 68 opens up to 9, well then what does 57 open up to? It's got to open up to something less than 9, because its angle is less than 68. So that means that we couldn't have a situation where then 57 also opens up to 9. So the corresponding parts need to be across from the same angles. Super crucial for these. All right. What information turned out to be essential? What didn't? So what has to be there? So we already showed you only need 2 angles. You don't actually need the third one, because if you know 2, the third is locked in. So up here, I could have erased the 35s or I could have erased the 30s. It wouldn't have mattered. You could have even erased the 115s. So all we need is 2 angles and 1 side. So you need 2 angles and 1 side. And there's 2 different configurations that we can get with that. So turns out we have both of them represented here on this page. Look here. We got 2 angles and then the side in between them. So 2 angles and then the side in between them. We call that ASA. If we have ASA congruence, where the 2 angles match and the side in the middle matches, guaranteed congruent triangles. Similarly, this one, we've got the side and then angle and then angle. Side, angle, angle, 9, 68, 57. They're equal to each other in that order. So we usually call that angle, angle, side. Some people like to write side, angle, angle. It does not matter. It does not matter. It means the same thing. It means that there are 2 angles in a row and then a side next to them. And if that's congruent, then we got congruent triangles. So, sweet. All right, on for quick notes. Sorry, I've been watching a lot of the Wiggles with my kids, and they're Australian. All right. So, if triangles have 2 sets of congruent angles and 1 set of congruent sides, then the triangles are congruent. I don't feel like writing the full words. You can write full words for these. I could have written this as a complete sentence, but I know what these symbols mean, and if I'm trying to take notes quickly, it's in my best interest to use symbols whenever I can. So the 2 that we came across were ASA. So a nice little diagram for that one. It looks like this. We got the angle in the middle and then the 2 different sides. And then the angle, the side in the, the side in the middle and the 2 different angles. The side in the middle, the 2 different angles. Well, I think I could have drawn this maybe a little worse. Let me try one more time. So we got a side and then we got the 2 angles surrounding it. So what if I had the side over here? Well, then I could still have the 2, as long as it's the same 2 angles surrounding it. That's the important part. So this would be angle, side, angle. And so if this was A, B, C, and this was D, E, F over here, the way we would need to name this to have them work right, if we called the first one A, B, C, triangle ABC. Well, look, A's at the double, right? So which one is at the double here? E. So this is gonna have to be triangle E. So it goes double, cross the side to B. So double, cross the side to F. So E, F, D. Remember, that second one gets named by how we write the first one. All right, so that's ASA. Then we have AAS, angle, angle, side. So I'll draw 2 triangles. Let's say we know this one and this one. And then I'll say this one and over here. And then we know a side next to it. So I'll just say it's this side. Here's the important thing on this one. This angle, the double angle is across from the side. So in my other triangle, the double angle would have to be across from the side. The order of these things from the first to the second, they have to be in the exact same order, even if it's turned. Okay, so in this situation, if we had A, B, C, and D, E, F, let's see. So if I called the first triangle A, B, C, then the second triangle Well, A was at the single, and F was at the single, so we would start with F this time. B crosses the side, so then F crosses the side to D, and then B to C. Well, that's our last angle, our last angle. Okay. Excuse me. All right, let's just keep going. So determine if the triangles are congruent. If so, write a congruent statement. Justify using one of the names. All right, if not, explain why not. All right, let's see. So 36.5 is across from 2.5. 36.5 is across from 2.5. Our other angle is 72. Our other angle is 71.5. Those angles were supposed to be the same. 36.5 across from 2.5 is good, but that's no good. Here's the thing, though. If you do that subtraction, see what you get. If you get 71.5, well, oh, you do. So in this triangle, the missing angle is 71.5. Well, then in this triangle, the missing angle is 72. Oh, it's fine. They are the same triangle. We have the two angle. Well, no. I've got the angle and the angle on the side. No, I don't have any of the initial setup. But now that we know all three angles, you could say this is ASA, because we've got that. You could say it's angle, side. Either one of those, once we find this third angle, it's enough information. Oh, pardon me. So we could really say either one based on how you want to talk about it. It's both. All right, let's look at our next one. Oh, these are so all over the place. So we've got a single mark, a double mark, a double mark. So I've got two angles, and then look, they have a shared side. So let me try to explain why that shared side is, we mark that with a congruent marking. Let's take these two triangles and split them apart. So everything's the same. That's the single, that's the double. Split apart. That's the single, that's the double. How long is this side? We could just put a marking on it, right? We could say it's this long. But if it's this long, then in the other triangle, it's this long as well, because it's the same side, it's the same piece of material. So now we have angle, side, angle. So a little tricky to see when they share a side, but that's, whenever they share a side, you can put a congruent marking on that and be like, hey, it's congruent to itself. All right, let's see. What additional information is needed to prove the triangles are congruent by ASA? Let's see, I've got two angles in each of them. I would need this side in the middle. Then they'd be congruent through ASA. All right. So now we have a proof. So the first thing it tells us is UWV and MKV are congruent. That is given because we see it in the picture. It's got the marking on it. Then there's another given. Oh, this is really hard to see, but these two were marked. So UV is congruent to, now you can't just write, you got to write it in the same order. You can't just write VM or MV. There's one way that we can write this. So if I wrote starting out here, traveling inward to that angle, well then I'll just start out here, traveling inward to that angle. So MV is the right way to say that. And there's one thing else that we can't see, but we've got this situation. That angle and that angle have to be equal to each other because they are vertical angles. So I could say angle U, that's V, right? UVW, angle UVW is congruent. Come on, congruent, there you go. UVW to MVK. Because they're vertical angles. So now I've got two angles that are equal and the side after them, right? Because it's that angle, So angle, angle, side. I can write this again. UVW, MVK, angle, angle, side. All right. Onward to homework. So I'm not going to do the entire assignment, but I'm going to walk you through it. So on this one, just try to figure out which angle situation it is. Oh, excuse me. So you can use this as a resource when you're trying the homework. I'll give you little hints on stuff, and the harder ones I'll probably do. In this figure, YI is the angle bisector of FYH. All right, let's talk about that. So YI is the angle bisector of FYH. Angle bisector means it cuts in half. So whatever this angle is, we know that this and this are congruent to each other because it's cut in half. It also says that YI is the angle bisector of FIH. So this angle is cut in half. It's not the same halves, it's a different size, but we can put and say that one's split into two congruent pieces as well. And then it shares a side. We just finished talking about this like 2 minutes ago. So what can we do there, and then what does that bring us to? All right, let's look at our next one. Now, I led some students astray on this next one. I was way overthinking this question. Ms. D wants all of her students to draw the same triangle. Determine if each set of directions would fulfill her goal. Give a reason for your answer. So we look at these and we say, hey, if everyone makes a triangle that has 9, 21, and 13, is that going to guarantee that everyone makes the same triangle, or is there a possibility you can make more than one triangle? Well, this is SSS. Wait, that makes two triangles congruent if they have the same three sides, so yes. Now let's look at this one, because I see angles and sides. So I'm gonna, let's see, it looks like it's X, Y, and Z. No, not A. X, Y, and Z. So X to Y is 13. Angle Y is 59. Measure of angle Z is 46. Oh wait, angle, angle, side. So yes. Let's look at our next one. Angle, angle, oh, we get 3 angles. Remember, that wasn't enough, so that's a no. And then let's look at this one. Let's see, C, D, and E look like there are 3 letters. So let's see, C to D is 16, E to D is 13, and the measure of angle E is 63. So I'm gonna pause and give you a chance to think about this one. I have 2 sides and an angle. And sometimes that worked, and there was one situation that didn't work. So just a reminder, that one situation is when we have the side, and then the angle after it. And if you write this backwards on a test for me, it's correct, I don't care. I'm not saying that other teachers will not care, but I will not care. If it helps you remember it, I'm happy. All right, let's see. This one, I will draw this to your attention, and I will say, are these congruent? Question mark. Then you can read through it and try it. Question 5, Arby's and Durnian shown. We want to show that Arby's and Durnian using SAS. So what other information do we need? Well, these are vertical angles, so we know these are congruent. So now I have a side and an angle. So I just would need this side and this side to equal. Now we have side, angle, side. Excuse me. If we wanted ASA instead, well, we had these two were equal. We knew this was equal. So then we would want this angle up here and down here to be equal. Is OP equal to Y? Let's see. OP, Y. Well, I've got angle, angle, side, angle, yeah, angle, angle, side. So I glossed over that a little too fast. If I am starting at this angle, I have to skip some stuff to get to that side, so we don't go that way. Instead, start at this angle and I can jump to that angle. You go to the one that is closer, that has less things in the middle, less things in between. And so that is angle, angle, side. So they are congruent triangles, and then OP starts at nothing, goes to double angle. WA starts at nothing, goes to double angle. Yeah, so that is the same order, the same side, so yes, I explained it. Angle, angle, side. And OP corresponds to WA. All right, and question 7 is a little tricky. Big idea in number 7 is that since these angles are parallel, that symbol means parallel, so then we have alternate interior angles here if you kind of look at it like this. So those are congruent angles, these are congruent angles. Wait, these are congruent angles because they're vertical angles. So all the angles are equal, and then they have a congruent side in between the single and triple. So, yup. Let's see, that'd be ASA. So then if I'm doing VZY, that was double, single, triple, then I can do TSY. So, cool. Well, a little bit of a crash course in ASA and AAS. Now we've covered most of the congruence theorems that we're going to learn about. And have a great day. And I'll see you soon. Bye.